So the format of the recording is I'm going to go through the questions. If you have any questions, you can ask them at the end. So I'm going to go through the content and then I'll pause and take questions and answer, and then we'll go through the past paper questions. So we are going to begin. Preparations of gases. The syllabus requires us to prepare carbon dioxide, ammonia, and oxygen gas. Now, to prepare carbon dioxide, we react metal carbonate and acid. You will commonly see calcium carbonate. Another name for calcium carbonate is limestone or lime chip or marble chip. So you have to be aware of that. So calcium carbonate is limestone or marble chip. So we react that with hydrochloric acid. Note, we can use hydrochloric acid or dilute nitric acid. We do not use sulfuric acid. The reason being is when calcium carbonate reacts with sulfuric acid, it forms calcium sulfate. Calcium sulfate is insoluble, so the calcium sulfate will coat the calcium carbonate, and it stops the reaction. So we're only going to produce a small amount of carbon dioxide if we use calcium carbonate with sulfuric acid. So generally in the lab, we want to prepare dry carbon dioxide. So to prepare dry carbon dioxide, we'll use anhydrous copper, calcium chloride, which is, these are drying agents. Silica gel. Silica gel is usually the pouch we find in our clothes, in our shoes boxes. Those are silica gel. Those are used to remove moisture. Or we can use concentrated sulfuric acid. No, we use these drying agents for carbon dioxide because none of these drying agents will react with the gas. None of these will react with the gas that is being formed, right? Then we have displacement in air. It is an upward displacement in air. So meaning that when carbon dioxide is produced, it causes airs to go up. So carbon dioxide is more dense than air. All right. Carbon dioxide is slightly soluble in water. And the reason for this is when we have carbon dioxide, which is a reaction we're going to look on later on today. Carbon dioxide can react with water to form carbonic acid. So some amount of it will dissolve. So if we collect it by water, we will not get all the carbon dioxide because a small amount of it will react with our the water to form carbonic acid. Now here is the setup. We have a tissue funnel which contains so we have a tissue funnel which contains the dilute hydrochloric acid or whatever gas we are using. Then we have the marble chip there. So of course, when the hydrochloric acid is added, it's going to produce carbon dioxide. The gas is going to enter this delivery tube and it will come over this gas jar, which contains silica gel, or we can use calcium chloride, or we can use or we can use concentrated sulfuric acid. So the purpose of this is to dry the gas. Then the dry gas will be collected here. We're collecting it downward because it is more dense than air, so it's upward displacement of air. So carbon dioxide is collected down. As carbon dioxide enter the gas jar, it's going to cause the air particles to rise. So here we are. Calcium. So we're going to prepare ammonia. Now, ammonia gas is prepared by reacting an ammonium salt and metal hydroxide. When that happens, we are going to form We're going to form a salt, ammonia gas, and water. So for example, here we have ammonium chloride and calcium hydroxide. How could that go so? Yeah, second. So example, we have ammonium chloride and calcium hydroxide. So ammonium chloride is NH4Cl. It's going to react with calcium hydroxide. Calcium hydroxide is called slake lime. Can use it in a solid state. Generally, it's too solid with heat. And then we are going to form a salt. In this case, the metal is calcium, so we're going to form calcium chloride. It's going to be aqueous because water is forming. So although these are solid, because we have water forming, we are going to have a small amount of the calcium carbonate dissolving in the water. And we have ammonia gas, of course. So we're going to balance this equation. So we need two chlorine. So we're going to put 2 in front of the ammonium. So we have 2 nitrogen. So we're going to put 2 in front of the ammonia gas. So we have 2 nitrogen, 8 hydrogen, 2 in water on the left, and 2 times 3 is 6. So we have 6 hydrogens on our right. That is balanced. 1 calcium, 2 oxygen. 1, 2, 8. Why am I oxygen name now balance? 1, yeah. 8. Oh, 8 and 2. So for hydrogen, we have more than 8 hydrogen. I said 8. So we have 8 here. That 8 is balanced, but we have an additional 2 here in the water. So we put a 2 here to balance out the oxygen. So the 2 oxygens will be balanced. So hydroxide bracketed 2 means we have hydroxide twice. So we have 2 oxygen. That 2 oxygen is balanced when we put the O there. And we now have 10 hydrogen on the left, 10 on the right. 2, 2 is 4, and 3 times 2 is 6. 2, 4 is 8, and 2 in the hydroxide give us 10. So our equation is balanced. All right, so the drying agent that we're using is calcium oxide. The reason why we're using calcium oxide is because the other substances that we have as drying agent, those will react with our calcium, with our ammonia. So ammonia and calcium oxides are both bases, so we're not going to have a reaction. We cannot use sulfuric acid because sulfuric acid will react with ammonia to form salt and water. Ammonia is a base. So when acid reacts with base, they form salt and water. So we cannot use concentrated sulfuric acid as our drying agent. Displacement of air. No, ammonia is less dense than air. So it is going to displace air downwards. So we're going to use upward delivery to collect ammonia because ammonia is going to be lighter than air. So it's going to go to the top and air is going to come to the bottom, right? Now, here is what we have for the setup. We are heating here the 2 solid, which is the ammonia salt and any metal hydroxide or metal oxide. We heat them right here. Then the gas that is formed upon heating is going to come here, and this gas is our ammonia gas. Or ammonia gas will come via this gas tube here, and it will pass through the drying agent, which is our calcium oxide. And because ammonia is more dense than air, ammonia is going to be collected right here, right? So it's different from how we collected carbon dioxide. And again, we are not using sulfuric acid or any other drying agent because those will react with our ammonia gas. So when we're choosing a drying agent, we have to make sure that our drying agent does not react with the gas that we are forming. No solubility in water. Ammonia is very soluble in water. This is because ammonia reacts with water to form aqueous ammonia. So it reacts with water to form aqueous ammonia or ammonium hydroxide. This reaction is reversible. So it forms ammonium hydroxide or aqueous ammonia, right? So we cannot use water to collect the ammonia because the water is going to react with the ammonia and won't get any ammonia gas forming. So that is it for our preparation of ammonia gas. So let me know. All right, so we have moved on now to preparation of oxygen. Oxygen is prepared in the laboratory by the decomposition of hydrogen peroxide using manganese dioxide as our catalyst. So hydrogen peroxide, H2O2 aqueous, will decompose in the presence of manganese dioxide, and it will produce water, liquid, and oxygen gas, right? So to balance this equation, we put 2 in front of the peroxide, 2 in front of the water. To dry it, we're going to use anhydrous calcium chloride, silica gel, or concentrated sulfuric acid. So the drying agent for calcium is the same as, for oxygen, sorry, it's the same as the drying agent for carbon dioxide. That's because oxygen is not reacting with any of these. No displacement of air, it's going to cause air to move up, and because oxygen is more dense than air. So as a result, we're going to collect it by downward delivery. So the delivery is downward, the displacement of air is upward displacement of air. So students tend to mix this up. Oxygen is slightly soluble in water, so we can collect it over water. Only a small amount of it will dissolve in water. So this is our setup. We have a tissue funnel that's going to deliver our hydrogen peroxide. Then we have our manganese 4 oxide or manganese dioxide in our flask. So what is happening is that the oxygen gas, so this is a catalyst. So what it does is speed up the reaction. So hydrogen peroxide can decompose on its own to form water and oxygen gas. However, manganese dioxide can speed it up. The reason why it speeds up, what it does is it gives more of the molecule their activation energy, so the reaction can proceed faster, right? So it causes more of the hydrogen peroxide molecule to so it lowers the activation energy, sorry. So more of the hydrogen peroxide molecule will have the minimum amount of energy to react, so they will combine, they'll decompose faster to form water and oxygen gas. So the oxygen gas is going to go here. Again, just carbon dioxide is going to go into our, pass through our drying tube, and then oxygen is collected. All right. So that's it for preparations of gas. So at this time, we're going to test what we learned. Feel free to answer the question. So Jamil wants to prepare carbon dioxide gas in the laboratory using calcium carbonate. Write a balanced chemical equation, including state symbol for the lab preparation of carbon dioxide gas from calcium carbonate. So what will we react the calcium carbonate with? We're going to react it with hydrochloric acid. Please give me the formula of the products that are forming. This is where you talk what we form.
Calcium chloride
Mhm.
and carbon dioxide,
And what else?
hydrogen.
water. So once you have carbonates or oxides or hydroxide, we always get water. Just write it on this handout so I can just send it to you guys after the class. Let me just edit it here. I draw a clearly labeled diagram to show the arrangement of apparatus and material used in the preparation and in the laboratory to prepare and collect carbon dioxide gas. So I have a flask. I used the wrong something, right? All right, that's afterwards. So I have a flask, right? And I have a tissue funnel that will go into my flask. Some you can draw. This is my tissue funnel. This would be my gas, my delivery tube, entering it into a gas jar. Collect it via downward delivery, upward displacement of air. So here we would have our calcium carbonate. This is our tissue funnel, and we have our HCl there. Then we have our gas tube, our delivery tube, and then this is our gas jar with, so we can have, so in our tube, we can have concentrated H2SO4, or we can have silica gel or calcium chloride. Whichever one, those are drying tube, and then we will have our carbon dioxide being collected here. Wash it on this. Thank you. Throw it out. Ready?
Yes, miss.
The apparatus below can be used to prepare dry sample of both oxygen, so one dry sample of oxygen and carbon dioxide in the laboratory. So what's going to happen is we have liquid X. In our tissue funnel, we have solid Y. So of course, each of these are going to require a different substance. Then we have our drying agent here, which is our liquid Z, and then we have A. So we want to complete the following table giving the identity to X, Y, and Z when preparing each gas. So for oxygen, what's the liquid that we use when we're preparing oxygen? What liquid come from our tissue funnel?
Hydrogen peroxide.
So we have hydrogen peroxide. Then solid Y would be our catalyst. What's the catalyst we use in preparing oxygen gas?
Manganese oxide.
The manganate dioxide or manganate 4 oxide. and our drying tube. Our drying agent is a liquid. Which of these are liquid drying agents that we would use?
Sulfuric acid.
So we have carbon dioxide. No, not Justin this time who's answering. Liquid X would be what? Liquid X would be
Dilute HCl.
HCl.
And what's solid? Why?
Calcium carbonate. Marble chips.
Our limestone. And liquid Y would be the same concentrated H2SO4. Clear?
Yes.
State the function of liquid Z. What we use Z to do?
Dry the gas.
So it's used as a drying agent. Another substance that could be used to perform the same function as Z. So we need a drying agent that can dry carbon dioxide and oxygen. What could we use?
Calcium chloride.
So we can't use calcium oxide to collect, to dry carbon dioxide because calcium oxide would react. So if we use calcium oxide, so we cannot use that one because calcium oxide would react with carbon dioxide gas to form calcium carbonate. So we cannot use this one. So we would use calcium chloride. What else?
Silica gel.
Silica gel.
What else?
Oh.
What method would we use to collect carbon dioxide at point A? So at point A, we're using upward or downward delivery.
Upward.
Or downward delivery.
Onward.
So it's upward displacement of air. So that is what kind of delivery?
Downward.
So using downward delivery, because carbon dioxide is more dense than air, we have to collect carbon dioxide downwards. Give a reason for your answer. So here's where we'd write the CO2 is more dense than air. Draw an apparatus that could be used to collect and prepare a sample of oxygen if you did not need the sample to be dry. So if we didn't need the sample to be dried, we could we would have our funnel still. That means you can't draw. The pen is not helping me. So I would have my my peroxide, my MnO2 here, and have water. Water and water in my measuring cylinder. Water is also in a measuring cylinder. And because I don't want it dry, I can collect my wet gas here. So instead of drying agent, I'll collect it over water. So I'll have a measuring cylinder full with water. And then as oxygen form, it's going to displace the water for me. Name the reagent you use to prepare a sample of dry ammonia in the laboratory. Sorry, so how do we prepare dry ammonia in the lab? So we need an ammonium salt. Can I have an ammonium salt, please?
Ammonium chloride.
Ammonium what? Sulfate. Because we used chloride a while ago. And we need a base. So I can use calcium oxide this time. I'm not sure if it asks for equation. Let's look to see if it does. Okay, so we're going to use the equation just to get a different practice. So ammonium sulfate solid plus calcium oxide solid forms calcium sulfate water and ammonia gas. So 2N, so I need 2N here. 4H is times 2 is 8H. So I have 2 H's plus 6 H's, so that's 8H, that's balance. One calcium, one sulfate, one oxygen. So my equation is balanced. Name the drying agent that would be used. So the drying agent that we would use is what?
Calcium oxide.
Explain why Z in the apparatus shown on page 105 could not be used. So it could not be used because it would react with ammonia to form salt. So we have H2, SO4, and ammonia. So what we're going to have is the formation of the ammonium sulfate. So balance it by putting a 2 here. So we have 2 H's, 2 times 3 H's, 8 H's, 4 times 2 is 8 H's, that's balance. 2N, 1 sulfate, 1 sulfate. So if the ammonia reacts with sulfuric acid, we're going to form ammonium sulfate, which is a salt. So we wouldn't get dry ammonia anymore. We're going to get ammonium sulfate. Why? But what method, sorry, would you collect the ammonia? So ammonia would be collected via which displacement of air?
Upward, downward.
Upward.
Downward.
Oxygen and carbon dioxide is collected by upward displacement of air. We would use what?
Downward.
So we're going to use downward displacement of air. And the reason for this is our upward delivery. And the reason for this is ammonia is less dense than air. Why could you not collect ammonia over water? So why we're not collecting ammonia over water? So it's very soluble. And if they had asked for the reaction, ammonia gas reacts with water to form ammonium hydroxide. 1N, 3 H's plus 2 H's is 5 H's, so 4 plus 1 is 5 H's. one oxygen, one oxygen. So it's balanced. All right. So here is the January 2025 question on ammonia. So it says nitrogen gas is used in the manufacturing of ammonia gas. Say two properties of nitrogen gas. So it is inert. Anybody else have a property of nitrogen gas?
It's brown, miss.
And nitrogen dioxide is brown.
It's called.
Any other property of nitrogen? So nitrogen dioxide is different from nitrogen gas. It colorless too and odorless. It's in the earth, so it's colorless. We're not seeing it in the atmosphere. So I'd add colorless. We have odorless as well. And it's inert, so it's not gonna react. Colorless, odorless. Physical, would inert be a physical property or a chemical property? Maybe inert would have been one chemical property. So I'm gonna say colorless and odorless. That's what I'm going to use. So draw a label diagram of apparatus to show how the preparation of ammonia gas. So you're gonna draw this. I'm not embarrass myself by drawing anything else because like this is ridiculous. So you're going to have your ammonium.
No, miss,
You're
it's
going to
not
have your ammonium
embarrassing.
salt and your base. You're going to heat it. Then you are going to have a gas tube or a delivery tube coming from here. And the drying agent, which is calcium oxide, and then you have your ammonia being collected there. So that's what you would draw there. Pretty not embarrass ourselves anymore. So it says, write a balanced equation for the reaction that takes place in the laboratory preparation of ammonia gas. What ammonium salts do you want to use this time? What base do you want to use?
Ammonium chloride.
Okay, what base do you want to use? Give me a base. We're not using calcium hydroxide because we use it already with ammonium chloride. Give me another one. Give me
Sodium
another base.
hydroxide.
Huh?
Sodium hydroxide.
Okay, let's use that one. We've never used that one. So that's pretty good. So we're using ammonium chloride. So tell me the products that are going to form.
Sodium chloride, ammonia, and water.
All right, so let's balance. 1N, 1N, 4H, and 1H, 5H, 3H, and 2H, 5H. 1Cl, 1Cl, 1Na, 1Na. So this is balanced. Explain why concentrated sulfuric acid, a typical drying agent, cannot be used in the preparation of ammonia gas, and identify an appropriate alternative drying agent to be used. So why can't we use sulfuric acid? We've been saying this from morning, so it will react with ammonia to form what?
Salt.
Salt and that.
More specifically, what's the name of the salt?
Ammonium sulfate.
Good. Ariel, why you had trouble my laptop for? Drying agent would be
Calcium oxide.
briefly describe a laboratory test for ammonia. We have two tests. You're going to give me both of them. So I'm going to put one test here and the observation on the other test here. Who's going first with this one? I've overtaught this concept. So who's going first?
Moist red litmus paper.
Must be moist.
Yes. And then it's going to turn blue.
So, say, boys, red litmus. Observation turns blue. Give me the next one. Glass rod with
Hydrochloric acid.
there must be concentrated HCl. And what's gonna be our observation if ammonia gas is present?
White foam.
White fumes. Okie dokie, so we are done with the preparations of gases